some final examples of being able to perform operations on functions and then also find the domain. We have these functions f of x is equal to root x minus 1, and g of x is x minus 7. We're going to add, subtract, multiply, and divide, but first we should find the domains of each of these. Notice we have an even powered root, and so that means that whatever's underneath has to be greater than or equal to 0. And so that means that if we add 1 to both sides, x is going to be greater than or equal to 1. For this one, this doesn't have any denominators. It doesn't have any square roots or fourth roots or anything like that. So that one's going to be all real numbers. Okay, so we don't have to worry about that one. So the only domain restriction so far that we see is that x has to be greater than or equal to 1 based on everything that we've seen so far. So now we can go ahead and perform the operations. Okay, so first operation is addition, and that just becomes square root of x minus 1 plus x minus 7. And there's nothing we can do with that. So that's going to be f plus g. We can clearly see, though, that the domain restriction is the same as before, okay, because we still have that function. So for our domain, we're going to say that x is an element. Since x has to be greater than or equal to 1, that's going to be from 1 to infinity. All right, so that's our domain on that one. In the same respect, if we have f minus g, all we're going to do is just take the square root of x minus 1 minus the quantity of x minus 7. So just be careful with that because it's a minus. And now this becomes the square root of x minus 1 minus x plus 7. All right, so just be careful with those minuses. Sometimes we just forget the parentheses. Right? Once again, we still have the same expression that holds the domain restriction. And so the domain is going to be still from 1 to infinity. A third example, f times g. So once again, we're going to have square root of x minus 1. And this time it's going to be times x minus 7. All right. And notice we really can't do anything with this. I mean, if we really wanted to, we could kind of distribute, and we can make this x root x minus 1 minus 7 roots of x minus 1. But we really can't do much else. All right. So it doesn't really add any value for us, at least initially, that I can foresee. That we could, where we go through and multiply it. So this would be an acceptable answer. This should be an acceptable answer. Once again, we still have that x minus 1 in there under the radical. And so our domain is going to be x as an element from 1 to infinity. Okay, so far so good. Not too bad. Last one we have is f divided by g. Now this one's going to produce another domain restriction. Okay, so we know that this is going to be the square root of x minus 1 divided by x minus 7. Nothing we can do with that. Okay, we're stuck with that. We can't simplify it. However, what we can notice is that right here, we know that x has to be greater than or equal to 1, which we've seen 4 other times. And right here, we know that the denominator suggests that x minus 7 cannot be equal to 0, or x cannot be equal to 7. All right, so these are our two domain restrictions. Now, let's graph this on a number line. And we know if 0 is here and 1 is here, all right, we know that we're going to include 1. And like somewhere along the line down here is 7. And there should be an open circle at 7. And we just shade in the rest of this. And so it looks like that we're going to have like a discontinuity or a hole there at 7. And so our domain is going to be x is from 1 to 7, including 1. So bracket on the 1, but parenthesis on the 7, and then union 7 to infinity. Okay, so anytime there's like a hole in a number, you just use like these two parentheses right next to one another. Makes it really easy for you. Right, and so that's how we go through and try to do some operations on our functions and then find the domains of those functions. All right, so in our next videos, what we're going to do is we're going to be taking a look at compositions of functions. In other words, how do we put a function inside of a function? And then finally, in the last section, we're going to break those apart and try to figure out what two functions would need to be composed to create another function.